So again, just like we did for exponential, let's try to see the derivative of logarithmic function. So we go in 4 ways also. We start with the logarithm with natural base. Okay, log to base e. That's what we write as ln e. Okay, so we'll start with that. No, log ln x, something like that. Then we can use the chain rule to extend it to when you don't have a normal function like x. We use chain rule to extend it. Then we look at the case where it is not a natural logarithm, where it would be to base a. Of course, a has to be greater than 0. What would that look like? And that's actually very easy too. And at the end of this summary, I want you to take a look at the formula booklet again after, not now. Then you will see that everything that we have established today is written there. So there's no need to memorize. But it's always good to know it. Okay? So, for logarithm to base natural logarithm, if y is equal to ln x, I'm interested in dy dx. Now, ln x is actually logarithm of x to base e, right? I can actually change this to index form and write exponential y equals x. Do you agree? Alright? So, now it looks like my dependent variable is x and independent variable is y. They change position. So I can say, okay, let's find the x dy instead. Instead of dy dx. Now this looks like exponential something. I'm differentiating the exponential y with respect to y. What do I get?
Exponential y.
Exponential y. Do you agree?
Yes.
I'm differentiating the exponential y with respect to y. Because now I'm finding the x dy. Right? So from here, my dy dx is just going to be 1 over exponential y. Can you see that? But my y is this. And what does this give you? Right? So you get what? 1 over x. So derivative of ln x means just flip x. Okay? Derivative of ln x is just 1 over x. That's all. If you extend it to general functions, okay, if y on the other hand is natural log of f of x, not x alone. Y is natural log of the function of x. You can use chain rule. Let's u be f of x, then y is what? Yes? Y is what? Come on, speak louder and faster. Lin you, please stop being spectators in my class. Speak. Okay? So from here, what can we find from this? Speak louder. I can't hear you. Thank you. U dx. And that is just f prime of x. From here, what can we find? Good. And from here, if you have ln of something, derivative with respect to that same thing is just to flip it. So this is ln of u. Derivative with respect to u will be what? 1 over u. Then we can use, okay, chain rule, dy dx is dy du times du dx. Okay? And that will be dy du is 1 over u. Du dx is f prime of x. So if you put it back, you actually have 1 over f of x, yes, multiplied by f prime of x. So all this, you still have to multiply by the function. The same pattern we noticed in chain rule itself, the shortcut to chain rule. After you treat it as one variable, you multiply by the derivative of the brackets. And the same trend we've been seeing now. So when you have the natural log of a function, you flip the function, multiply by the derivative of the function. Does that make sense? So, but that is one part. The other part of this is when you have a base that is not e, logarithm to base a raised to power 0, where a is not e. Okay, that symbol is such that. Okay, so we are talking about if y is the log of x to base a. If we can figure this out, then we can extend it to other functions by using chain rule again. Okay. So this is actually easy because we can change the base to base e. I have x, I have a here. Do you agree? Why do we change the base to base e? Because we already have the result. So the entire y can be seen as ln x over ln a. This is simply 1 over ln a times ln x. Why did I separate it? Can somebody tell me why I decided to separate it? Say that again?
You need to flip that.
Not really? Why do I separate it? Why do I think separating it like this will make my life easier? What? No. No, this is after we differentiate. I'm rewriting my y before I differentiate. Why do I say that? What? That's not why I'm separating it. I'm not asking for the derivative yet. Why do you think I separate? Not yet, wait. You probably have an idea, I don't want you to say it. Why do I think it's necessary to separate it? Because the next thing I want to do is dy dx. But I chose to write this in this form. Why? Because it's a constant. So I can see it clearly. This is your k f of x. So I can see it clearly. It's a constant. So when I differentiate the constant just step aside while you take care of the derivative of the function. And the derivative of this function is this one. Just turn it upside down. Okay? So what we are saying is that if you have logarithm to any base, it is simply 1 over x ln a. Logarithm of x to any base, it is simply 1 over x ln of that base is x. So if this was, for example, log of x to base 3, so your derivative is simply 1 over x ln 3. That's what we are saying. It's a gradient function. We'll apply this on Zoom tomorrow. Okay? Now let's extend this so that you take the last 5 minutes to either wrap up what you are doing or just have a free time. Let's extend this to other functions. So if y is the log of f of x to base a, okay, we apply chain rule. Let's do it together. Yes? Speak louder, please. Lillian, can you turn that off? Sorry. I can hardly hear when you guys talk and you are not speaking louder. The mask is blocking us enough. Yes? Let's u be f of x. So from here, if u is f of x, then what? Y equals log of u base a. Below this, we can find what? Du dx. Okay? When you say derivative, it's two, we don't know if it's derivative with respect to what, just say du dx. Okay? And what is that? F prime x. And from here we can find what? dy du. And from what we already know, well, this one is equal to what? 1 over u ln a. Does it make sense? So now
dy dx by chain rule is dy du times du dx will be equal to what? 1 over u ln a times f prime x. So if you write that properly, it's going to be 1 over u is f of x ln a, then times. So you see, everything is always times the derivative of the function because of chain rule. Okay, so I'll put the summary here. I'll take a picture. We apply this on Zoom tomorrow, and you can take your weekend to do more. I will encourage you to do more. So I've separated the practice of exponential from logarithm. Take your time to do your practice, okay? So I'll put the summary now. Please spend the next 2 minutes to either copy this or the summary. Don't turn off yet because I want to put the summary. So in summary, oh, I need you to check the formula booklet and confirm that all these are there. You will see for SL only. I think for SL only in exponential it's only e of x. But I think for HL it includes a to the power x. Yeah, you see? SL only is just e of x for exponential and ln x for logarithm because these are the easy ones. Derivative of exponential means just copy and paste, right? For, I'm talking about the first one there. Derivative for ln is just flip it. Is that not? So that's why that is for SL. But if you go to the HL part, you can see a to the power x, and you can see logarithm to base a as well. Does that make sense? So no need to memorize. This will be available test or exam, but at the same time it's always good to know. Once you do it more often, you will always remember. So for logarithm, that is just 1 over x. For logarithm of a function of x in general, it's 1 over function times the derivative of the function. And for logarithm, it's a of x. 1 over x a, and in general for logarithm of f of x is a, it is 1 over f of x not x. Is this what we summarize? Is this our summary? Yes? So please take note. It's very easy to remember. This is the same format. You just need to multiply by the derivative. Okay? And this one is same format, just that x of x is being replaced by function of x, and the derivative of that function of x needs to be multiplied by it. Alright? So this is where we stop. Thank you very much.